In this lecture, we are going to discuss how to simulate stock prices. Although many beginners tend to be overly enthusiastic about trying to accurately predict future stock prices, price simulation is actually much more useful. Simulation helps you understand how your algorithm will behave under uncertainty. You can't only test your algorithm on historical data. You want to be confident in knowing that your algorithm works. You want to be able to say, my algorithm is robust, and my algorithm doesn't lose lots of money when the market is bad. This lecture will focus on the basics of how to simulate the evolution of a stock price. The best way to understand this is with pseudocode. We're going to look at two methods of simulating stock prices. The first method is to take all the historical returns from a given stock and then sample from those returns in order to generate future stock prices. The pseudocode goes like this. First, let's assume that we have an array of returns that we've just calculated from our data. Recall that you already know how to do this. Next, we start with some arbitrary start price. We can just set it to be the final close price in our dataset. Next, we enter a loop. Inside the loop, we sample a return from our list of returns. Then, we generate the next day's price by taking the previous price and multiplying it by 1 plus the return that we just sampled. You should be able to confirm, based on our earlier discussions, that this formula is correct. Finally, we save this price to our list of prices. At the end of the loop, our list of prices represents one possible future progression of the stock. Another way to do a price simulation is this. As you recall, it's possible to fit a distribution to the returns. So far, we've seen that the t-distribution and the Gaussian mixture works pretty well. Let's assume we fit a t-distribution. This gives us back the parameters df, location, and scale. Again, we set the initial price in our simulation to be the final close price in our dataset. Then we enter a loop. Inside the loop, we sample from our fitted distribution. This gives us a sample return. Then we use the same formula we had earlier to find the next day's price using this latest return. Again, we save this price to our list of prices. And at the end, we have one possible future progression of our stock. So you can see that the only difference between this algorithm and the previous algorithm is how we sample the returns. One way is to use actual historical returns, and another way is to fit a distribution and then sample from that distribution.